Good morning, Year 8. Today is the 26th of April, 2020. We're now on week 4. We're going to move on to now lesson 1 of 4, 12.3 histograms. So histograms are very similar to bar charts. Histogram is usually used to show continuous data, while a bar chart is used to represent discrete data. Histograms are also often used for group data. I will explain this a little bit more further in detail as we go along. But the main use of histograms is, so when you do your graph, so instead of having separate bars, which shows it for discrete data, with histograms, the information is represented by bars which there's no gaps in between them. Now these bars aren't called bars in histograms, they're actually called bins, B-I-N-S. Let me just rewrite this. So they're called bins. And what you'll see also is that these bins, the area they take up on the bar, so example, so the length and the width of these bins, represents the data they're showing. So anyway, we'll move on to an example. So for example, look at the heights of 25 children measured to the nearest centimeter. So these are the measurements of 25 children. Now, if you also use a graph to show this data, like so, like a line graph, this, you can see it's not very informative. You can't really say much from looking at this data because this data is what we say continuous, measurement, instead of counting the individual children. Representing like this is not very, useful for us as someone who's looking at this information. Okay, so this is why it's not very useful, in that the bars, these lines, it doesn't really tell us about how the distribution of the heights of the children we're looking at. So, to make this information more useful for us, we say it's better to construct a group frequency table. So what we do is, where we've got all this information here, so instead of drawing it individually for each piece of data, it would make more sense to group it into what we call intervals, class intervals. And then, as you can see, you do the tally. So you go through your data. So between 135 to 139 centimeters, we say there was one child, so the frequency was 1. 140 to 144, there was 3 of them. So again, if you go look at the original data, we say, okay, between those two measurements, there's 1 of them. Between the other 2 class intervals, there was 3 of them, and so forth. So this would all be grouped. Now, what you're going to be careful with here is, when you do your class intervals, make sure the interval width, if you like, is the same. So if you notice 135 to 139, it's 4. Between 140 to 144, 4. 145 to 149, 4. And another thing you might notice also, that the 2 don't interlap. So when you're looking at data, say for example, a child was measured at 133, let me write this a bit more clearly, 133, that child's height would go into this class interval. If somebody was 139, again, it would go to this class interval, not here, because there's no overlap. 139 stops here, it starts at 140. So if some child was at 140, it would go into this class interval, not into this class interval. So once you've done the table and you've marked off the tallies, and then you write down, okay, there was frequency of 1, frequency of 3, frequency of 4. You can see here from the straws where the status, where these numbers are coming from. You would then draw your histogram of this data, and remember, put the title, so histogram of heights of 25 children, and here on the y-axis, we've got the number of children, and on the x-axis here, we've got the class interval. So from 135 to 139, the frequency was 1, 140 to 144, the frequency was 3, 145 to 149, the frequency was 4, and so forth. So notice how there's no gaps in between the histogram. So this is, like we said, is continuous data. Okay, and then from here you can see the distribution of data more clearly. You can see that here there was there was a very short child between 135 to 139, and here there was a very tall child from 165 to 160. But here we can see in the middle part here, if we do this as our curve bell, then we can say that the majority of the data, we can say almost like 95% of the data was in this region, and only a very small amount, or we normally say this kind of distribution, so there's 2.5% here and 2.5% here. And this is true for whatever large amounts of data we look, when we draw the bell curve, which was developed by the famous Austrian mathematician Gauss, and they're actually called the Gaussian curves. This is, from him. Okay, so moving on. So here we've got question 2. So question masses in kilograms of 25 children are given to us. So between 10 and 19, there was 1. Between 20 and 29, there was 4. Between 30 and 39, there was 7. And between 40 and 49, there was 12. Between 50 and 59, there was 1. So to draw this information, draw a histogram, and what is the modal? Now the modal, remember, is the highest frequency, one with the most common number, occurrence we see. So if we look in our data here, we can see that the modal class, we don't know what, some children could have been weighed 41, 42, 49. We don't know that. All we know that there was 12 between 40 and 49. So we can say the modal, one that had the highest number of repetition, if you like, was here. So we can say the modal class was between 40 and 49. Because this is group data, we don't have individual weights of each child. All we can say is from the group data, we can say that the modal class was here. So I'm going to show you the solution to the first question just to give you guys a bit more understanding. So if you do it, so again, remember you've got the number of children here on your y-axis, the weight on the x-axis, you put your mass here, and then you draw your bins and make sure you've got your axes, the scale is going up in even numbers. So you can go up in 2, 4, 6, 8. You could have gone up in 1, 2, 3. But then obviously that would make your graph really big. So it makes more sense to use 2, 4, 6, 8 to capture the data on the graph. It makes it easier to read. Again, if you look at the distribution of data, we can see that it's not an equal symmetrical. If I had my line of symmetry here, you can see that a lot of the data is actually here, whereas a very small distribution of the data is there. But that's, for later when we do a bit more advanced statistical analysis. But the thing you expect to be able to do today is to draw these histograms. So remember, there's no gaps in between the data. These bins, as I said later when we look at it, the area they're occupying your graph represents the data you're looking at, and make sure you use sensible axes to show this information. So for question 3, the heights of 30 plants in centimeters, 6 weeks after planting were given here. So between 5 and 9 centimeters, the frequency was 5. Between 10 and 14, the frequency was 9. Between 15 and 19, the frequency was 8. Between 20 and 24, the frequency was 6. Between 25 and 29, the frequency was 2. So again, draw a histogram to show this data. So again, think to yourself, okay, this is going to go on your x-axis. These are your measurements, and the frequency. Put these on your y-axis. Okay, then draw your bins, and then look at how the data is distributed. So pause the video now, do the work, and then press play, and then we'll look at question 3, the solution. Okay, so hopefully if you've done it, you can check your work now. So here we have our distribution of the data for those number of plants. So you can see that there wasn't that much difference between the tallest plant and say the smallest plant. I mean, there is a difference, but the number of, there was only 2 plants that grew to only 25 to 29 centimeters, whereas a lot of the plants was growing, the average was between 10 to 14 and possibly 15 to 19. So the most of the plants were growing to this height, whereas, your outlines with the plants that were growing either very, very short, very, very tall, was few in between. Again, and that's to be expected. So if we look at normal distribution of weight or heights of children of a similar age, we will see a lot of them would be around in the center. You would only find a very few students that were either very, very tall or very, very heavy or very, very short and very, very, underweight. The majority, 90% of people would fall in this range here. For question 4, the heights in centimeters of 30 different plants were measured 6 weeks after planting. The results are shown in this histogram. So here's a histogram of a different set of plants, and here's the frequency. So here it says copy and complete the table. So you've got height 5 to 9. Now you got to feel this, so 5 to 9 would be around here. So you see the frequency there, you would have put was 12. Now what height give you the frequency of 8? Well, you can read across here. So 8 was a height between 10 and say 14. Don't go to 15 because 15 is already, you don't want the overlaps here. So this goes 5 to 9, this goes 10 to 14. And again, you can see that there's a difference between the class intervals. What we see, the lower and upper limits is 4. So this will be 4, this is 4. So 15 to 19, if I look at here, 15 to 19, the frequency would be 6. 20 to 24 is here, and we could say that's about 3. And the last one would be 25 to 30, which will be here. So then you do the table correctly, properly, and then do the comparison. So the comparison is looking at 2 things. So if you're looking at the distribution of data, histogram on question 4, and then compare it to how the data is distributed in question 3. So you've got 2 different plants. How are they similar? How are they different? Do you think these plants are the same species? If you think yes, how? You need to justify your answer. If they're different, how would you be able to support your argument in that they're different? So look at how the heights of these 2 plants are distributed. What is same? What is different? Okay. So for your answers, here's the answers to question 4, A and B. So none of the plants in question 3 are generally taller, as the modal class is 10 to 14, rather than 5 to 9 in question 4. However, it is difficult to say as we do not know the growing conditions for both groups of plants. So we can make some general assumptions, but we've got to be careful that we can't make too generalizations. Okay. For question 5, Vendra counted the counted the words in the first 40 sentences of the book. Here's her findings. So draw a histogram for this information. And what is the modal interval? So again, which one has the highest frequency? Okay, so again, pause video, do the question, and then we'll go through the solution. Okay, so assuming you've paused and you've done the work, let's check, see how question 5. So here's question 5. Here's a histogram of the number of words from 0 to 9, 10 to 19, so forth. So here's what your histogram should look like. And then what is the modal? So which one had the highest frequency? So if we look again, it's this here, 10 to 19 had the highest frequency. So that would be our modal interval, 10 to 19, which is again the same here, 10 to 19 is our modal interval with the highest frequency. That's our mode. Question 6, the waiting time in minutes for 25 patients. The C doctor is recorded here. So construct a frequency table using interval. So you have to do the table first, you know, like your tally chart table. And then think, okay, what do I set my class intervals for? So I've got, in looking at the data, so what's the lowest data you have? You have 8 and 4, going all the way up to the largest data is 50, the longest minute, so it's 51, 48. So, you know, you need to think, okay, I've got 25 pieces of data and I need to put them into equal tables. So think, and my smallest data, so, you know, I need to capture, so the first table would need to capture the numbers from 4 to possibly 8. And then your next set of data, you need to go from 9. If you're going to keep it even, you know, intervals, so say maybe that goes up to 13. Then your fourth goes from 14 to so forth. I mean, this could be one way of doing it. You could think of a different way of doing it. I'm not saying you have to do it like this. You choose how you would do it. And then do your frequency table. And from your table, so remember, you got the class intervals here. And then your frequency, so you're going to have your tally, say so 1, 2, 1, 2, 3, 1, 2, 3, 4, 5. Put the frequencies here. And then from that, then draw your histogram to illustrate this data. And then from there, work out how many patients waited less than 10 minutes. So to do that part, what you would do is from your histograms, so let's say your histogram look something like this. So say this had a frequency of 4, this had a frequency of 5, and this had a frequency of 7. So if the question was, what, you know, how many people had frequency less than 7? So you're counting this bin here, so that's 5, plus this bin here, 4. So the frequency less than 7 would be 9. So again, read from your histogram, amount of data, you know, less than this, and then work out the percentage. So remember, percentage is the smaller number out of the total number. Total number is 25. To work out how many percentage, which is half an hour or more, so that's 30 minutes or more. And was your interval choice the best? So do you think grouping your data with differences of, you know, going up in 4s was better, or do you think it would have been better if you went up with class intervals of, say, 10? So you went from, say, 4 to 14, and then 15 to 25. So again, looking, you know, compare that method to maybe slightly different method. So again, pause the video, look at what you've done, do the work, and then we'll check the final answer. So the question 6, they use, you know, as you can see, a class interval of going up in 4, so 0 to 4, 5 to 9, 10 to 14, 15 to 19. So there was the frequency. Here's the distribution of that data. Now 40 to 44, you can see here, was 0, so they just left it blank, was the waiting time. And then question 2, you know, 30 minutes or more. So 30 minutes is basically here. So with 30 minutes, so that's 5 here, here is 4, here is 0, here is 2, and here is 2. 5 plus the 4 is 9, plus 11 is 5 plus 4 is 9, plus 2 is 11, that's 13. So 13 out of 25 total to give you a percentage of 52%. So again, if you did your class intervals differently, do you think the way you did it was better than doing that class intervals for? Do you think maybe doing at 10 would have given you better results? It's something to think about for the future. So those are the 6 questions we're doing in today's lesson. In tomorrow's lesson, we will move on to stem and leaf diagrams. But for today, these are the 6 questions for you to do. If you have any questions or you're stuck, please message me and I'll respond to you with an access code for the Zoom session. And then I can give you a more individual one-to-one support on any of these questions you're stuck. You know, enjoy the rest of your day. and I look forward to seeing you guys for the rest of the week.